Hello everyone, we're Team 2 and we're excited to present our project proposal focused on Tesla supply chain. To set the stage, here's a quick snapshot of the electric vehicle industry. EVs are growing rapidly, about 40% each year, mainly due to stricter climate regulations and the push for energy independence. Top players in the space include Tesla, Rivian, BYD, and Lucid Motors. Tesla stands out because it doesn't just make EVs, it also controls much of its supply chain, like battery production and energy systems. At the heart of EV innovation is the lithium ion battery. It is what powers the vehicle and gives it range and performance. Tesla has invested heavily in this through its gigafactories, which are designed to produce batteries faster and more efficiently. Now, let's look at some key challenges and trends in the EV industry. One of the biggest issues is the shortage of raw materials like lithium and cobalt, often sourced from regions with environmental or ethical concerns. Another major challenge is transparency. With global supply chains, it's hard to track where materials come from, making it tough to meet ethical standards. And then there's this issue of battery waste. As EVs grow, so does the need to recycle used batteries properly. But there are also some exciting trends. More companies are starting to build their own batteries, which lowers costs and gives them more control. There's also a growing focus on sustainability. For example, using blockchain to trace materials through the supply chain and designing batteries that are easier to recycle or reuse. So, overall, while the EV industry is expanding quickly, it also faces some major challenges, especially when it comes to creating responsible and sustainable supply chains. Next.
Okay, let's dive a little deeper into the challenges faced by not only Tesla but the broader EV industry. First is the complexity. The EV supply chains are deeply global and multi-tiered, which makes visibility and coordination difficult. One disruption upstream can, like a delay in raw material, it can ripple all the way down to the final product. The second major concern are the ethical concerns, particularly about the cobalt mining in the Democratic Republic of Congo. Not only does this raise human rights issues, but they also threaten Tesla's ESG compliance and brand trust. Third is a significant gap in the battery recycling infrastructure. The end-of-life batteries are piling up, but the systems to extract and reuse these materials are still in their initial phases, which makes it extremely hard for Tesla, in its ability to close the loop and reduce reliance on minerals. Next slide. Okay. So let me give you two examples of how Tesla responded to these supply chain risks. First was the lithium shortages. So Tesla was initially relying heavily on foreign lithium suppliers, which led to delays. What was their response? They built a lithium refinery in Texas, which cut lead times and secured domestic supply. This showed their vertical integration, and it also showed how vertical integration can directly boost resilience. Second one was the battery waste. With the EV sales surging, Tesla faced a growing stockpile of used batteries. So they partnered with Redwood Materials, recovering almost 95% of the critical minerals like lithium and cobalt. This move not only reduces the dependency on mining, but also feeds a closed loop recycling system. Together, both these cases highlight Tesla's shift towards resilient, ethical, and circular supply chains. Over to Gauri.
Thank you, Ashwin. Battery waste and recycling. One major challenge Tesla faces is the rising volume of end of life battery. To address this, Tesla partnered with Redwood Material, a company specialized in battery recycling. Though this partnership, Tesla now recovers by 98% of materials like lithium, cobalt, and nickel. This is the key step in building a closed loop system where use battery and recycling use are reducing the need for new raw material and minimizing the environmental impact. Next slide, please. Tesla at a glance. Tesla is currently a large EV manufacturing in world. Its main competition is with Rivian, BYN, and many more other motor industries. The company follows a vertical integration model, meaning it's controlled most of its production from battery development and assembly. Tesla operates operations are over all global scale production in such as countries like US, Canada, China, and Germany. Strategically, Tesla focuses on battery innovation and broader sustainable energy solution. It's not just a car maker, but it's as a clean energy leader. All over to Hari.
Yeah, even though the Tesla is a leader, it still faces some big supply chain challenges. First, there are critical ethical concerns, especially around cobalt mining in the Congo, where working conditions are often unsafe. Second, Tesla has low traceability in supply chains. Since they work with the mainly suppliers across the world, it's hard to track where every materials come from. And the third, Tesla is still working on how to handle a battery disposable. Right now, their recycling system for the old batteries isn't strong enough, which creates waste and lost valuable materials. Now we'll see what are we solving. Our project is focused on solving this problem by making Tesla batteries supply chain more sustainable and transparent. We aim to increase the use of recycled materials to 30%, which can improve tracking of materials using blockchain used by up to 80% traceability. This includes better recycling system, using technology to track materials, design batteries, or easier recycling and training supplies. All of these plans over the next 12 to 24 months with a clear budget, and the budget will be covered by the Nikhil.
Thank you. To enable Tesla's transformation into sustainable and transparent battery supply, we have outlined a strategy of 6 million investment plan across four key pillars. The first largest share of 2 million is allocated for recycling infrastructure. This will help us establish a closed loop system to recover over 95% of critical materials like lithium, cobalt, and nickel. This more significantly reduce the independence of mining and supports Tesla's environmental commitments. The next 1.5 million is planned for the blockchain integration, enabling an end-to-end traceability for mining operation and battery recycling. This not only improves the transparency but also supports the ethical sourcing and compliance with the global sustainability regulations. The other 1 million is reserved for the R&D in circular battery design. By designing batteries with recyclability in mind, we can improve the material recovery rates and simplify the end-of-life processing and reducing almost our overall waste. The final 1.5 million will be towards the supplier onboarding and training. This ensures that all the Tier 1 suppliers aligns with the Tesla's sustainable goals and equipped with the necessary tools and fulfilling the blockchain tracking systems. This budget plan is designed to be scalable, impactful, and aligned with the Tesla's long-term vision of becoming a benchmark in green revolution. And Tesla's vertical integration model creates an ideal foundation for building a sustainable and circular battery system by integrating the global supply chain and transferability and closed loop system. This helps to reduce the environmental impact, enhance the brand value, and mitigates the geopolitical dependency. This proposed strategy aligns with the global climate mandates and sets an industrial benchmark in ethical sourcing and EOL management. Thank you.